All right. So plan for today is we're doing the we are starting the dimensioning, a little more dimensioning, advanced dimensioning practice. But this is the first video for first period. And the way it's going to work is because the overall goal is to dimension every part from the part file, from the green sheet. I'm going to be doing half of them in first period and the other half in sixth period. And so we already did part A and B in first period, and I'll put up this video is going to be part C and D, probably, maybe more. But because it's the first one for first period, I'm going to do the introduction portion of what we're doing and then go into part C and D dimensioning, because it doesn't really matter the order that we dimension the parts from the green sheet. We're going to get them all, but yeah, just with enough practice. All right, so here is the situation. First, some technical stuff. We are going to be in Inventor, and we're going to make a new drawing file. And this drawing file is going to be similar to the one from the Puzzle Cube, where we had one drawing file, but with several sheets to have everything organized. And I would like to have, I guess you can move them around pretty easy. All right, well, then I guess we could do these out of order. There you go, that's the thing. We're gonna have one drawing file with 12 sheets, one for each of the different letters, parts from the green sheet, and they are each going to be a multi-view, front, top, right, top right, 4 views on the same sheet with dimensions. That the point of this is not for you to just make these sheets and throw dimensions on there. It's to learn the process of dimensioning and putting dimensions in the right location and not over dimensioning, and so on. Now, first, technical issues of if you didn't do all of the green sheet parts, you're going to have trouble with doing this, because in order to do the multi-view of something, you need the file that it's based on. Okay, so if you are someone who does not have all of the green sheet shapes, you need to acquire them. Now, the way you're going to do that is from your main folder window. You're going to find the handout folder, which is down here. You may have never used the handout folder before. You're going to go to Holt. And again, this is only if you don't have all 32, all letters and numbers of the green sheet. Okay, handout Holt. It's in period 1 and period 6. Right click on green sheet parts, that folder, do copy, and then right click on My Documents and do paste. And the reason for that is, even though you could, in theory, open up and make drawings from the parts directly from this handout folder, it's not, I don't want to do this, I want to cancel that. That could be bad. You're not going to be able to make changes to them the way you would if you had, ownership, and that's why you would make a copy. But again, that's only if, is there an undo? I shouldn't have done that. So either way, first you need to have all of the parts, all of the part files. Step 2 is make a new drawing file. And we, like I said, are going to have one sheet for each of the letters. This drawing file is going to have 12 sheets, one for each of the 12 letter parts. And each sheet is going to be a multi-view, like I showed before, with top, right, and center. So let's start by getting our 4 views on the sheet, and then we'll talk about the right place to put all of the dimensions and the mantras and trade-offs and that sort of thing. So we're always going to start with a base view. You're going to click on the Finder button and choose the part file that you want to start with. Let's start with part C for now. Hit open. Now, a couple of things happen automatically. First, because of the way that we made the part, it's going to guess this as your front view. And for the most part, for almost every single one of the green sheet parts, the front view is the best front, or the front face is probably going to be the best front view, and that's just because of the way that we made them. But sometimes your best front view is not going to be the one that comes in as front, and actually choosing the best front view is part of doing good technical drawings. The front view is going to be the view that gives the most information as about that shape. Most of your dimensions are going to be on the front view. Most of the contours, around the outside are going to be on the front view. And for now, we'll just go choose this as front view. Okay. Then as far as scale goes, again, a coincidence that a 1-to-1 scale seems to work well on the size of our sheet. This is a complete coincidence. Your drawing might come in and 0.25 might be the right size if you're drawing something big. The sheet itself has built-in dimensions. It's based on an actual piece of paper. I don't think it's our traditional printer paper, but is that 8.5 by 11? It might be, but oh no, it's probably not. But the 1, 2, 3. No, it's a much larger than it, because this is 9 inches across. So this is a giant piece of paper. Anyway, based on the size of your actual part file, you're going to need to scale it, but you want to scale it so that it takes up most of one of the corners or quadrants, one of the quarters of the paper, so that you can fit 4 views comfortably. You definitely don't want them overlapping the edges or each other. In fact, to start, I'm going to make this 1.25, and you don't have to actually do 1.25 to 1, just to show you what slightly too large looks like. And you can change it very easily. So we're going to put our front view down here in the bottom left, and that's our base view, and hit OK. Then we're going to go to projected. Click on the view we want to project, which is our front view. And actually, I'm going to get rid of some of these toolbars so that we get a few more pixels to work with. Okay, so I am viewing this one, the front view. So I clicked on that, and now I click up here where I want my top view. You'll notice that it lines up exactly. Even if I move my cursor left and right, it doesn't make it slide. It forces it to line up exactly, unless you go past a certain point. But either way, top view there, right view over here. Okay, you can see it just gave the outlines, which it's supposed to. And you can see it's starting to get a little crowded, even though our front views sort of look like about filling up one quadrant of the page. Either way, I'm going to go ahead and make my top front right corner view here. We'll do right click, create. Once you have your 3 projected views, right click, create, and you can rearrange them. The top view can only be arranged up and down because it has to line up with the front view. And same thing with the right side view, can move left and right. If you want to move the location of all 3, you need to move the front view because they're all always going to be tied together, which is critical. And even if I rearrange things, it's a little tight. So I'm going to go back to the front view, do right click, edit view, and change the scale to just 1 and hit OK. And it will update the other 2. Editing view or edit viewing on, no, it's definitely editing view on one of these orthographic views, which are these, doesn't change our isometric view. So we need to right click edit on that and change that to 1. Can't decide if I want to stick with our hidden or shaded or unshaded view. I don't think shaded adds that much just because it's monotone, and yeah, we'll just stick with our basic unshaded, the default. All right, so this is our base for this, and we're going to add in under annotate. Dimension is our main tool. It's also hotkey D for dimension. And it is a lot like dimensioning the part view, or excuse me, dimensioning the part itself, dimensioning the sketch before you do the extrusion when you're making the actual part. Except the difference is that the reason you put dimensions on it is to show how big something is rather than to change and constrain how big something is the way that you would when you actually built it. And that goes to the entire point of this. The point of this is a sort of a blueprint that you could give to somebody and they could recreate this part exactly from only the information on a single sheet. That's why you need multiple views. The multiple views, if you just had a front view, you could give all of the height and width dimensions that you need, but there's no way to explain what's happening here without some sort of depth view. Okay, same thing here. We don't know that there is a notch here unless you have the top view. But the key is knowing where to put these dimensions to make sure you have enough dimensioning that you've fully dimensioned it so that somebody could recreate it, but also making sure you don't have too many dimensions or over dimensioning or redundant dimensioning, because even though these are very simple parts, if you had the total width dimension twice, nobody's likely to be confused. But if you have a super complex part and you start throwing in redundant dimensions, it can quickly get out of hand. And that's sort of one of the principles of dimensioning, is keeping it neat and tidy for the sake of avoiding confusion. So that's what we're going to work on. All of the rules for dimensioning and processes are about avoiding confusion, avoiding lines crossing over, avoiding lines, dimensions on the part, trying to dimension to the contour, okay? Meaning this location right here, okay, either this line from this side or this line from this side, they're dimensioning the same thing, even though they're different numbers. You are giving the horizontal location of this feature. The problem is on the front view, you can't really tell what it is. You just know there's a line that is 7 inches from the left or 2 inches from the right. On the top view, it shows that is referring to this sort of cutout in the front right. So the dimensioning of the location of this line should be on the top view. Okay, and it's a lot about trade-offs, which is the better place to put it. Same thing with hidden lines. So the height of this ledge, which theoretically we could put the dimensions on the isometric view. In fact, I think that looks pretty cool, but that's not what we're going with. The height of this ledge is 3 inches off the ground, but that means we either need to put it, let me get rid of these extra dimensions. And in fact, I have a plan. Let me see here. Let's go back here. I'm going to make a new sheet with part C except super small. I think that will make the actual dimension lines larger. So now when I annotate, yeah, there we go. Okay, so your dimension lines will not be this big because your sheets are going to look like this. I have made my multi-view here just so you can see things better. That's, yeah, so there's that. All right, so we need to, okay, so these dashed lines are hidden lines. And that's because when you're looking, this is a right side view. When you're looking at this part from the right, you can't see this edge, or really this edge, you know, this surface when you look from the right, but it is projected with a hidden line right there. Okay, so this is referring to the height of this ledge, but so is this. So we have a few options of where to dimension the height of this. Okay, dimensioning over here would be dimensioning to that hidden line. And dimensioning here would be dimensioning where it actually is showing the shape. Not ideal because it's not really a contour. You could dimension here, but then we have extension lines crossing onto the view, and we don't want that. Okay. I don't expect you to have completely internalized everything I just said about choosing locations, but that's an example of the process of choosing the best location to give a particular dimension. But the key is that we only want one of these, because otherwise then you're over-dimensioning. All right, so the actual rules, as I have declared them, in our spreadsheet, there is a folder or a link to a folder called Dimensioning Documents, and it looks like this. And the two files that we're going off of are Dimensioning Guidelines and Dimensioning Standards. These are PowerPoints. And Dimensioning Standards is a little more formal in that it's actually talking about what the different marks on the page are. Okay, extension lines are the really skinny lines that go up to but don't quite touch the part. Dimension lines are the arrows that stick, that point away. The dimension text is the actual number. And normally, let's say in past years, we have done all of our drafting technical drawings on paper before we went to Inventor. And I think you guys actually are missing out on a little bit, because doing it on paper forces you to learn all of these conventions, all of these standards. But it's just so tedious to do everything on paper first that there isn't really a world in which, even if you went into drafting, design, engineering, whatever, that you would be doing stuff on paper. So much of this is done for you. You can kind of just gloss over it. All of these standards that the extended lines extend past 1/16 of an inch and stuff like that. That's for the good old days where you get out your ruler and actually do stuff on paper. But knowing about it is good. Okay, arrowheads are on this size and that sort of thing. And okay, you could have the whatever it's called, dimensions, either all pointing the same direction or have them lined up with the arrow. Okay, size, location, dimensioning checklist, blah, 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 blah. Okay, we are going to be doing what's known as stacked dimensioning. This is a chain dimension where each dimension of a certain, we'll call it direction, even though they are dimensions. I mean, it's like we ran out of words with, there's height, width, and depth, which are the three dimensions. Dimension is also the number that describes how far in height, width, or depth. Dimension is also the verb of putting dimensions on the drawing. So you're just going to have to learn it from context. But either way, chain dimensioning is where you're dimensioning one after another, and that's fine. But what we are going to do is what's called stacked dimensioning. And why is there not an example here? I thought there was one. Maybe it's on the other one. Did I pass it? Impossible. Stacked dimensioning is like this, where all of the dimensions of a particular dimension, we'll say direction, all of the dimensions in any of the directions are going to be measured from one of the sides. In this case, all the height dimensions are measured from the bottom edge. All of these width dimensions are measured from the right edge. And I think this looks much tidier. It also is a better way of making sure you get every dimension, and it works better for more complex things to make sure you're not missing dimensions. When we get to the backside of the green sheet, we will talk about how circles and arcs are dimensioned by their diameter or radius, depending on whether it's a complete circle or just an arc. Also, Inventor does that for you automatically. It chooses whether it's a diameter or radius based on whether it's a full circle or not, but that is for further along. The dimensioning guidelines slides is a little bit more useful in that it's going to address the issues of the choice of where to put a particular dimension. And one of the files here, Inventor, is this Inventor tips rules? No, dimensioning standards. That's not a good name for it. Let's call it dimensioning sins. We'll put quotes around it so nobody gets upset. Dimensioning sins. Okay, so each of these different options, when there isn't an obvious location to do something, like the front view is not the best location and it would cross over, or it's just not easy to put a dimension on something, we're going to go through the trade-offs, which is worse. Okay, putting the actual number on top of the view is worst case scenario. Having extension lines cross is not the end of the world, but it's one of the worst. You don't want to dimension the hidden lines or not go to a contour, not contour going to. Those are more about adding information rather than having lines cross. Sometimes your extension lines will have to cross onto the view itself, especially if there's some sort of internal feature like a hole or something. You would need, your extension lines need to go onto the view. Sometimes it's unavoidable. Okay, it would look something like that, except we can dimension the height of this line on the side. That's fine also in this case. And not going between adjacent views. That means if given the opportunity, you would want all of your width views to be like in this area. Come on, pen. All of your width views to be here, you know, between the top view and the front view. You would want all of your height dimensions to be in this region, ideally, because, well, there's that. And all of the depth dimensions to either be over here or over here. The reason for that is, again, all of these rules are designed to avoid confusion on far more complex drawings. But if you have the location of this line from here, but you have it over here, which crosses extension line, but again, just for the point of explaining this between adjacent views, the idea is if you're looking for the location of this on the front view and your eye has to travel up the page, crossing dozens and dozens of other dimensions for a more complex part to find that particular value, again, more likely for confusion, but it's really, that's why it's super low on our hierarchy. It's not that bad compared to these other things. Okay, there's no reason to overdimension. Again, overdimensioning is more stuff on the page that's unnecessary. And some mantras for deciding. If you didn't need the dimension when you built it, you don't need it when in the drawing. For instance, let's make a new sheet. Something like, I'm not jumping ahead to this one, but something like this one. Okay, and let's do like that, and projected of this. We aren't doing this one yet, but just an example. When we made this part, we never needed to know the length of this line. That was not a dimension when we made it. The reason why is because as long as we knew this dimension, and this dimension, we could just connect these points when we made it. So we didn't need to know that dimension. We also, I don't think on any of the green sheet parts needed to know an angle dimension. So I know if you're throwing in an angle dimension, you are just sort of throwing dimensions on there. And that's one of the things I'll look for when you're doing these on your own. If you are just throwing redundant dimensions on things, I know you don't know what's going on. All right. So the point is, if you didn't need it when you built it, you don't need it for the drawing. our process, our literal step-by-step workflow is going to be start on the left, and every time something changes, take another dimension or put another dimension, and then go down the hierarchy if it's not where you want it to be, if it breaks one of the rules. And then if it's not neat, it's wrong. Although, because it's Inventor and it does pretty much everything for you with arrows, touching extension lines, and choosing the best format for everything, makes it pretty easy. All right, so for first period, which this is our first, again, the introduction for first period, and no, that's not it. Let's go to this one. The video here, this video is the introduction you just heard that I gave for sixth period, as well as, hold on, wait for it to pop to the slide. There you go. As well as the dimensioning for parts A and B. I will put here intro and part C and D. I don't think we'll get to E today. Dimensioning. There is value for watching whichever one of the, well, I guess first period here that I'm recording this now is going to have to go back and watch the AB. We'll have one of these for each. And so I'll put this video up, and when we're done here in a second, let's call that other intro. I think this one is actually probably a better intro than the one I gave yesterday. Other intro and parts C and D dimensioning. And when we're done here, I will put, that's not how you spell dimensioning. I will put the video of the thing that is currently being recorded there. And we'll just link it there, even though there's no video there yet. All right, so let's go ahead and actually start building our drawing file and multiple sheets. So the overall goal is to have a single drawing file with one sheet for each of the lettered parts. We'll have this first drawing file will be parts A through L, I guess. And we'll have them in order at the end. But as I realize we can actually build them out of order and then rearrange them to be in alphabetical order, that's probably better than just going through them in alphabetical order because they aren't in order of complexity. So right now I have A and B done from yesterday, but you guys can go ahead and, well, I'll just build off of this one later. So you guys are going to start a new drawing file like that. It's going to start on its first sheet. And let's right click on the actual Word sheet in the browser bar and do edit sheet. And let's just name the sheet C. If you're watching this from sixth period, then you already have parts A and B done. So you would just go from place view, you would go new sheet and name that one C. And eventually all of yours, regardless of period, will look the same. So let's just go ahead and save this full drawing file and put it wherever you saved the parts themselves. Most of you, if you listen to my suggestion, what you put them directly into my documents folder, and you just have a list of full all of your Inventor part files there. And as long as you name them, something meaningful and descriptive, it's easy enough to find them. If you made subfolders for your different projects, great. If you just did the thing I said before, where you copied from the handout folder because you didn't have all the green sheets from the first time we did it, that's fine. You're not going to get double penalized for it. And you can use the provided, what happened to all of my, hopefully somebody didn't take them. Okay. You can do that copy and paste of the entire folder. But if you did that, wherever you save the folder, that's where you need to save the drawing file. You'll see that when you go to wherever you saved it, you can't see any of the other Inventor files because it will only show you whatever drawing files at this point. If you go to all files, you'll see whatever you have there, but you're not saving it as an all file. You're saving it as a drawing file and call it something good, meaningful, and descriptive, like green sheet letters or something like that. You don't need to put P6 or P1. Just green sheet letters is fine, saved in the same location. The reason why it needs to be saved in the same folder, even if it's not in a folder, the same sort of level, is because the drawing files need access to the part files themselves. They aren't copying the part file, they're referencing it. And that's actually a good thing because I already have P1? No. Stop doing that. It's not P1. Because if this is your drawing and you wanted to change something for a drawing that already exists, you could do right click on the part and go to open, and it opens the part file. And then you could change something about it. Let's make this 10 wide. Do finish sketch, and then save this part, and you go back to the drawing, and it should update. There you go. It updated it. So the point is, it needs access to that file. If you change the name of a file after you've used it, it won't work. We talked about that before. And if you save it in a different location, it won't be able to get it if you change the location. So just be consistent with your saving practices and whatever. All right, so we're going to go ahead and make part C. You're going to do base view, find your part C. Oh, wait, we already did this. You already made a base view for part C, which was base, find part C. Choose the best scale, which for you is probably going to be 1:1, and place it down here sort of in the bottom left quadrant so we have room for everything. Hit OK. Then projected view, click on the front view itself, go up to do top view, to the right to do right side view, and to the top right to do our isometric. Then do right click, create, and respace them as necessary. And that is our starting point. And we should go ahead and just do text boxes now. So under annotate, you can get a new text and make a text box like that. It will pop up. Let's just call this part C and hit OK. And it'll put it in the top right, but you can center it again. There's probably, if you highlight it and change the size, that'd probably look a little better. And let's put one for name right here. Even though this says drawn here, just put your name in that box. And I still have the text tool to right click OK. Then you can drag around the actual text thing to center. All right, so now we need to put some dimensions on here. The key, the mantra, the process, the first thing we're going to do is do our width dimensions. And we're going to start on the left side, and every time something happens, we're going to add a dimension, and that way it will end up being our stacked dimensions. We'll end up stacking in that manner with the smallest ones closest, and it ends up looking super neat. And by neat, I mean neat and tidy. I am going to do, like I showed before, my tiny drawings so that the actual numbers are visible. Yours are fine in that default small text. When you print them out or make a PDF, it'll still be plenty visible. You should still get used to moving around the sheet itself. It works a lot like the part file, where mouse wheel up is zoom out, mouse wheel down is zoom in, and press in the mouse wheel button and it gives you the grip hand. That's super useful. And the home key will zoom to fit the full page. There's these tools over here also, which do roughly the same thing. So there's that. And anytime you have a tool, right click, OK, done, or hit the escape key. That's pretty neat. Normally, it actually says there's a little icon of a escape key there rather than just the letters ESC in brackets. Anyway, so our dimensioning, let's save this as green sheet letters small. This is something else. This is going to be my drawing files that are small enough that you can see the numbers. Anytime you see this dialog box that has yes to all as a button, click yes to all and then click OK. It does different things in different scenarios, but the point is that you don't need to worry about it. Just do yes to all and OK. I'm going to put this back the way it was and save it and close it and update this from before. There we go. This will probably give me a yes to all. Nope, it doesn't. All right, so let's go to this. Okay, so we need to go through the process of dimensioning. We're going to do width first, width left to right, then height down to up, and depth front to back, which is fine. So our width dimensions are going to start here on the left side of the page, which is also the left side of the part, and work our way right. We want all of the actual dimension lines to, our goal is to put them here or here, sort of in this region between the different views, because that's one of our goals. So let's go ahead and start on the left and put our dimension on our front view. Okay, starting on the left side, the first thing that happens is this edge right here. You can't really tell what that edge does at a distance of 4 inches from the left. If you look at the multi-view, you can kind of see what it's referring to. But it's not ideal because it's not going to the contour, but there isn't really a contour from this because it's a flat. The other option, the other valid option would be to put it on the top view. You can't have it both places, but neither is really good, neither is really bad. So we're just going to put it there. Okay, going back to the left side, the next thing that happens is this edge right here, which is the distance to this, like that. But on the front view, it's not really ideal because from the front view, you can't tell what's happening at that distance. This angle doesn't show that it's actually a set back. It could be a set forward, it could be a diagonal, it could be curved. You can't really tell there, which is why this dimension we want to put on the top view, because you can see from the top view that it's actually the edge of the shape. It's a 90-degree turn that goes back this far. So this second width dimension is going to be better off from the top view. You'll notice as you go along that as you're actually placing the dimensions, you won't always get the entire line if you choose, if you click from the line. Sometimes you will, but a better practice would be to choose the actual points that you're dimensioning between. Okay, so you have the dimension tool, first click here, second click here, third click to set it. So that is the best place for that one. And the only other width dimension is total width, which technically speaking, total width always goes to a contour because it's the edge of the shape. A contour means the perimeter of the shape. So we only need one of these two. I will usually defer to the front view just because most of the dimensions are going to be there. I think it looks better. Okay, and that's it for width. Okay, now we'll do height dimension. Going from the bottom up, the first thing that happens is the height of this ledge right here, but our extension line crosses onto the view. We don't like that. Second option is going to be over here on the right side, but this is dimensioning to a hidden line, also pretty high up on our list of dimensioning sins. Okay, extension lines across the view is not good, which was our first option. This is extension lines going across the view. The other option was hidden lines, which is worse. Higher up on the list is worse. Our third option is putting the actual dimension over here outside of adjacent views. But that is the least bad of our list. And that's why we're going to keep it there. I'm going to delete these other ones. In order to delete a view, you have to cancel the dimension tool by either doing right click, cancel, right click, OK, or hitting the escape key on your keyboard. And once you do that, you can click on the dimension and delete it with the delete key or right click delete. And so we've handled this first height dimension. The only other height dimension is total height, which looks like that. And it goes to a contour, it doesn't break any rules. We're good to go. So that's it for height dimensions. Our only other dimension that we need to dimension with dimensions is depth. So depth is front to back, and front to back is either going to be on the front view or the right side view going that direction. That is front to back when you're looking at the right view. So even though this is to the left of this and on the page, and this is the right of the view, we wouldn't refer to it as the right and left. This is the front of the part. This is the back of the part. This is the front of the part. This is the back of the part, even though it's on the page in a different location. So let's do our depth dimensions working front to back. Okay, first option, starting at the front, working our way back, is this ledge right here. On the right side view, this first depth dimension goes to a line. You can't really tell what's going on. If we do that same dimension here on the top view, you can see that it's the dimension of a cutaway. So we're going to keep that one. And the only other depth dimension is total depth, which is between here and here, or between here and here. Having both of them is wrong. Having both of them is over dimensioning or redundant dimensioning. And in that case, you need to get rid of one of them. And they neither break a rule. They're both between adjacent views. Total width and depth always goes to a contour. It's all good. In this case, I think it looks better to have as many dimensions as possible on the same view. So I'm going to get rid of this one, but it doesn't really matter. Okay, and you want to space things out nice and even. And there you go, part C. That's it. Width left to right, height down to up, depth front to back. Okay, and save it. And this will be part C. Let's edit sheet, part C. And let's see, what do I have things going on here? Good. And so that's part C. Let's go on to part D, which we can just, I can look at it from the drawing file. So we're going to need a new sheet. So under place views, go new sheet. Let's rename it. Right click, edit sheet, and call it D. And let's bring out part D. So we'll go base view, and we'll go down to D, hit open. And I would say this is definitely the best front view. Again, you aren't going to have many hard decisions in with these part files because we made them from the best front view to begin with. So let's see here. Let's go edit sheet, call it D. Oh yeah, you can see this the default sheet size is called size D. And this actual piece of paper is 22 inches tall and 34 inches wide. So we would never print it out full scale. But you know what? I wonder if that would change things. If we did sheet size A4, which is what we normally have, 210, that's got to be millimeters. No, that's not good. Just trying to solve things for you guys so that the dimensions actually look good. That's 8.5 by 11. That's even worse. Oh, how would you make that like that? Is it one of these things? No, I don't want that. So let's just leave it as our default. You will be able to see the dimensions regardless. All right, so we now have our fourth sheet for some of you, second sheet for some of you, and we'll bring out the base view of part D. And let's stick with, I think our 1-to-1 scale will work fine. This is our best front view. Keep it down here in the bottom left. And there you go. Once we put it in there, maybe scale of 1 1/4 will work better for this. But either way, we'll get a projected view. click on the front view, go up to the right, into the top right, right click, create. And yeah, I think that's all right. I think 1 1/4 might get a little crowded, but if we just stick with one scale of 1 to 1, that should work fine. Okay, and now we're going to add some dimensioning. I'm going to make the tiny one so that you can actually see what's going on. Let's try half scale. And hit OK, and I'll do my tiny projected ones. This is not what you're doing. All right. So, all right. So let's work on our dimensioning process. Okay, we'll go to annotate and dimension. And start on the left. Every time something happens, take a dimension. Okay, on the left side, the first thing that happens is when this edge changes. Okay, I think that's still too small. Let me restart here. And I'll change this, edit view. Maybe 0.3. I'd like that to be in the middle. Ignore all of this. Nope, that's not what we want. Edit view. This is just for the example. All right, that's fine. Okay, so the first thing that happens is our the dimension of this first sort of pop-up, okay, from the left side. Perfect. Okay, this doesn't break any rules. It's between adjacent views. It goes to a contour, not a hidden line, not crossing over. It's beautiful. Okay, we'll go back to the left. Next thing that happens is sort of this side of that thing. And that's perfect also. It goes to a contour, doesn't cross over. Beautiful. And back to the left, going right. The only other thing that happens is total width. Perfect. Okay, height, down to up. First thing that happens is this edge right here, which is the height of this ledge like that. This is not ideal. It's not going to the edge of the shape. This is going to the edge of the shape. And so we're going to put it there. We aren't going to have it both places. And height-wise, the only other height dimension is total height. There you go. It could go here or here, but planning ahead, I think some of my depth dimensions will be better off on this view because it shows the contour of the depth, and the top view doesn't show any of the contour of what is actually being dimensioned. So I don't want this dimension, this height dimension on here, because then I might have some stuff crossing over, and that is to be avoided. So I'm going to just keep my total height there. Beautiful. All right, and so that's height. We have every time something happens, take a dimension. And the only other dimension is depth. And so we're going to do front to back. First thing that happens is the distance from the front edge to where this thing starts. But on the top view, I mean, it does kind of go to, it's not to a hidden line, but you can't really tell what's happening there. The same way you can tell if you put this first depth dimension there. So we'll keep that one. And then the only other depth dimension is total depth, which could go on the top view there or on the right side view here. Both are dimensioning total dimension. Neither breaks any rules. So that's just a what you think looks better. I will usually defer to having more dimensions next to each other. So I'm going to keep that one, but that total dimension works well there. Okay, then save your drawing. Yes to all, hit OK if you get that yes to all. And that's where we're going to stop it for today. I know that's a lot. But if you are at this point in first period, we only have these two drawings done. If you are watching this in sixth period, you will be A, B, C, and D. And again, I just realized that we can do these out of order in order of difficulty and then rearrange them as needed. Let's go ahead and put your, well, I'll keep this one as my formal one. Put your text information here. It's not critical that you make your text the same as mine, as in, what is this, part D? As far as size goes, or, you know, have them left justified or something, but yours all need to be the same. Meaning, if I have part C, if my text area for part C has the file name here and it's this size and it's centered, it needs to be the same on all of them. Okay, centered in there, and your name in the same place. This is a good place for name. And using that font size. Okay, and then save it. I'll put some dimensions on here just so this is what yours will look like. I'll show you how fast it goes. And there's height dimension, or the other one, width, total height, and then some depth. And once you do a few of these, that's pretty much how fast you're going to do things. And let's, so the dimension tool. This file is going to be my formal one of fully completed one. So we'll go 4. This one is 7. And then total width. And we decided the height would be better over here. First click, second click, third click. And total height and depth goes here. And so part D, part A, part B, and save it. So you have all of your sheets on the same drawing file, at least for letters at this point. And we're going to go ahead and stop the video there so we can post it as soon as